We are the 2024 Cedarville Solar Boat Team. Our team is excited to return to Solar Splash this year to compete, and we hope to score well in all events to win the competition. Our team is composed of all senior mechanical and electrical engineering students, and we have 2 faculty advisors that have helped guide us in this project. Cedarville placed second last year in the competition, but because of the rule changes this year, we hope to perform better in June. We're excited to be using new motors this year and have created some new test setups for our batteries and solar panels.
Hello, my name is Seth Hewitt and I was in charge of propellers for the Cedarville Solar Boat Team. This included endurance propellers, sprint propellers, and toroidal propellers.
In designing a conventional propeller, we first created a data set using OpenProp. This data set yielded propeller efficiencies which were then compared to motor efficiencies. This yielded an optimal design. This optimal design was then machined on a 3-axis mill. To create a toroidal propeller, we first copied the leading edge of a Sharrow Marine prop. With this leading edge, we were able to create a 3D model of the prop. This was then 3D printed.
Hey everyone, I'm Josh Zukowski and I'm responsible for our team's motors and motor controllers. For the past year, my chief goals have been to integrate our 2 new motors, a Peregrine 20 and Peregrine 40 from DHX machines, into our existing system and to have them operate according to our expectations for endurance, sprint, and slalom. This has involved a good amount of motor controller calibration and fine-tuning with both motors, along with testing on our dynamometer to evaluate our motors' performances and efficiencies. Besides troubleshooting electrical issues and evaluating damage done to motors from years past, I was also in charge of upgrading our existing cooling system to avoid any issues with overheating the motors during operation.
Hi, I'm Caleb Spreckles, and I was in charge of the solar panels and the energy management system this year for the Cedarville University Solar Boat Team.
My responsibilities for the year were designing, constructing, and implementing a new solar panel frame and array. After redesigning our array, I had to construct a new mount. This mount was made out of aluminum square tubing, which was welded horizontally, and the panels were attached to this horizontal part with screws and Velcro. We also cut flanges on the vertical components so we could rivet them to the horizontals, and then after this we had to screw in the peak power trackers and wire everything together. We also had to attach this frame to our boat hull, which we did by making custom bushings and then epoxying them into our gunnels.
Hello, my name is Henry Rockwett, and I'm part of the electrical projects team on the solar boat team, subset of it. My job this year was to work on the electronic load bank and update it from a previous design. We originally had an electronic load bank and it kept breaking and was not a very reliable design. It used an analog control circuit, which was hard to debug and hard to fix. So this year I've digitized the controls. I've also added a lot of data logging capabilities to maximize efficiency in our testing. And this updated device will give us valuable insight into our battery performance and our solar panel performance to give us accurate and competitive results for our races.
Our team has also spent a lot of time developing a boat that has hydrofoils. We hope to race with this boat for Solar Splash and Solar Sport 1 competitions in the future. Solar Sport 1 competitions take place in Europe and allow us to use lithium-ion batteries. This boat has one strut that comes down in the front and one that comes down in the back from the hull. Both of these struts have hydrofoils that we can articulate. The foils produce lift and are intended to lift the hull out of the water. Our goals have been to achieve flight on this boat so that we can continue to fine-tune its controls and race with it in the future. Hi, my name is Maria Smith, and my role on the team was to develop the flight control system for the hydrofoil boat. The flight control system is intended to automatically stabilize the orientation of the boat during flight, and it had been developed in the past as a state-space model in Simulink. My goal was to integrate this Simulink program onto a Raspberry Pi. The system needed to be compatible with CAN communication since that's what we use on the boat. I made a very simple Simulink program to learn how all these components can work together. This was called pass-through mode. It sends hydrofoil actuator set points to the hydrofoil actuators on the boat. We hope that future teams can integrate the more complex flight control model onto the boat in future years to stabilize the boat in flight.
Hi, my name is Caden Torgard, and I've had the privilege this past year of redesigning the rear strut on our hydrofoil boat. The reason behind the redesign was to fix the instability issue we found with steering. Once the redesign was done, I was able to make those designs a reality through the manufacturing processes we have at Cedarville University. Through the use of a CNC mill, I was able to manufacture complicated parts powered by the design. And all of this just brings us one step closer to racing our hydrofoil boat at Solar Splash in the upcoming years.
Hello, my name is Caleb Bainey, and today I'm just going to be talking to you about my project that I had as part of the Solar Boat team for Solar Sport 1. My part of the project was to build the lithium-ion battery pack that is actually going to power the boat, as well as controlling the battery management system on it so that we can not only use the power of the battery on the boat, but we can also have the power from the solar panels to be able to get onto the boat safely. The battery pack is made up of 176 lithium-ion cells that are all spot welded together to give us our capacity of 1500 watt hours, which is per the Solar Sport 1 regulations.
I'm Owen, and I was in charge of electronics, data acquisition, and display. My main responsibilities were to solve problems with the current boat electrical systems, understand the schematics. Our boat communicates using CAN communication, so I had to learn how to use that. That's what's used on cars. I also had to learn how to do Arduino communication, use Arduinos. I'm a mechanical engineer, so learning this really taught me a lot about electronics. My main responsibility, the task that I was working on this year, I was creating an auxiliary dash which helped us test the hydrofoil boat. So I put this on the boat and got all the electronics working around it so that we were eventually able to move each of the actuators, which moved each of the hydrofoils to its desired angle of attack, which eventually allowed us to test the hydrofoil boat.
Our team has worked hard all year, and we are very excited to compete.